Okay, great. So let's start with the session tonight. I think it's probably going to be a shorter one than normal. We're going to focus on straight lines tonight, and then next week we're going to focus on the financial maths component. So next week we will definitely focus on this basic financial calculations. And the reason why I didn't want to start that tonight is so that we can do that all in one session next week, so that we can go through all of those elements in there, and then we done with the contents for the subject. So then we're going into prep for the exams. So we will make sure that we get enough prep then in as well for the exams. And I know, Rebecca, you also shared your current exam date. So hopefully then we've got another 4 or 5 sessions, so that we can cover enough for the exam. Okay, so tonight, as we prepare for straight lines, the thing that is important, nearly what we're going to focus on is we're not really going to draw a straight line, because again, how your assignments and exams are set up, you can't really physically go and draw something. But what we will look at is, we're going to do it so that when they give you options of different straight lines, that you can nearly on your own, on the side, on a piece of paper, be able to draw it and then see which one of the 4 or 5 options that they give you will be the correct one. So I think that is important. So we'll draw the line. I'll show you within that straight line the things that we look at, so that you can plot it onto an axis, so that when we look at certain things, you can automatically see, okay, this line, it can be this one, some of the others it can't be. So we will definitely, there will be a big focus on looking at the lines, how to identify them. Within that process, we will also then look at how to determine the slope. So we will get to how to determine the slope. So it might be that we use a formula that we have for the slope. It might be that we need to read it off the equation if it is already given. So we will focus on how to identify the slope, how to look at that, how to calculate that. And then in the end, we will also then determine how the equation look like. So if it is by them giving you 2 points, that's on this line, we will calculate the straight line. If it is by giving you something on an axis, we will be able to show you how to determine that straight line, because that nearly is the importance of the things in this chapter, is that you will be able to identify from a few options which one is the correct straight line. You will need to be able to work out how the slope looks like, or what is the slope for number of it, and you will need to be able to determine the equation in the end. Okay, so that is the 3 things that we will focus on straight lines. The important thing is that with straight lines, we will be looking at always the quadrant graphs. So there will be a quadrant 1 that is always positive. So you can look at this as nearly your y values is always positive on this side. Your x values is always positive. So whenever we have a point in this graph, it is always positive. So in this instance, and remember your points is always x and y. So for that one, it would have been 7 and 5. Okay, so just if you always see if I give you a graph, always remember that the point in quadrant 1 is both always positive. When we move over to quadrant 2, so when we move over to quadrant 2 from quadrant 1, the y's will again be positive, because if we look at, say, that point, your y is still positive 4. But what now changes is we moved into the negative x area. So quadrant 2, the thing that changes from a positive to a negative is your x value. So in this instance, your x would have been -6. Okay, so from quadrant 1 to quadrant 2, the only thing that changes is that your x value becomes negative. When we move from quadrant 2 to quadrant 3, then both your x and y is negative. So if we had that point, that would have been x minus 2 and y minus 2. So when we're in the third quadrant, your x and your y is negative. Then nearly the last move is from third to fourth quadrant. Now still your y is negative. So if we had, say, a point there, your y is still positive, so -2. But we're now moving again back into where x is positive. So your x in this instance would have been 6. Okay, so that is nearly looking at the 4 quadrants. So whenever they nearly talk about that or show you things, because they can, and we will go through an example now, where they again will not ask you to plot it, because you won't be able to plot it on a multiple choice question, but they can give you the points with plots and say which one is correct, or is A, B, C, D the following points. But to be able to do that, you, in a sense, will need to know how to plot it. So we will go through that process of how to plot it, so you can again recognize it when you need to do it in the assignments. So just going back again, the quadrant 1, both positive, and you can nearly look at it from this point as view as well. Quadrant 1, both positive. The opposite of that is quadrant 3, where both will be negative. Quadrant 2, we've got negative and positive, and that will again change from quadrant 2 to quadrant 4, where the negative will become positive and the positive will become negative. So nearly you can look at the inverse every time. So quadrant 1, both were positive. Quadrant 3, both negative. Quadrant 2, negative, positive. Quadrant 4, positive, negative. Okay, so that's a basic look at the quadrants. Let me just quickly duplicate this so that we can make this a bit bigger. So it is just easier to see. And we'll do the same with this one. So again, so it is just easier for you guys to see. Okay, so with this example, I'm going to do the plotting. Then I'm also going to actually look at ways that we can look at the straight line. So just that we can start to identify certain things in it. Okay, so let me get to the pen again. Okay, so basically here they ask us to plot a point 2 and 2. So we know because it's both positive, it must be in quadrant 1. So 2 and 2 is sitting there. Then on the negative, or the second plot that we need to do is -3 and -3. So again, from the previous grid, -3 is in quadrant 3. So now we're sitting it in this quadrant. Okay, so what is very interesting here is that when you're gonna draw a straight line through this to get to the 2 points, it is actually going to go through. I can just get back to the normal view because now I see it's okay. So it will actually go through 0. You can also test it a bit on graph paper, or even just draw something that you have that one is like 1 centimeter, 2 centimeter, 3 centimeter. Okay, so what we will be able to do from this is nearly to say, but let's look at this and just a few things. So your normal graph will always look like this. In some instances, they talk about AX plus B or MX plus C. So depending on what study guide you have, what book you're looking at, between the different courses within decision sciences as well, we use different signs nearly for a straight line. But basically, the slope is A or the slope is M. And then your C is your Y cutoff. So in this instance, the C will be equal to 0 because it goes through that origin. So if we needed to start building a straight line, we could have already said, okay, but my C is going through this origin, it's 0, so my C will be equal to 0. So we'll get to how to calculate the slope now. but automatically we already then have an answer for C, and we will need to calculate the slope. Okay, so what I'm going to do is when we get to calculation of the slope, I will just come back to this one and we will complete that as well for you. Okay, so that is nearly looking at 2 points. If we connect the 2 points, we basically already have a view of a straight line, and we can start making assumptions of that. Okay, so the next one, again, looking at a few points. Here we have a negative x, positive y, so we will look at Q2 for that. And then the other one is actually a replicate nearly of, instead of Q1 and Q3, we have a Q2 and a Q4. Okay, so first one, -1 plus 3. So we go -1 plus 3. So that is our first point. And then our second point was +2 -1. Okay, so here we can also fit a line. Let's just assume it goes through those points, but I'm not 100% sure yet of what that is going to be. Okay, so again, after we've calculated the slope, we can come back to this one, and I'll just show you again how we will solve the rest of that formula, because at the moment it is mx plus c. I could not by 100% say it is probably going to go through 2, but I can't say with conviction it is going through there. So let's get to it, because when we have a way of calculating the slope, we will have a way of calculating the y-axis as well. Okay, so just showing you at the moment when we have 2 points, how to locate it or to show it. So what will probably happen with you in one of the assignments, and then in the exam, is what they might give you is, let's say, 4 graphs, and I've now just created quarter Q1, but they might say, okay, we've got points 1 and 3, 5 and 6. Which of the graphs is showing that? So it might then have been that there's 1 and 3 and 5 and let's say 6, but the other point is here. And it might have been that this is the correct one with the 2 points. Might be another one like that. Might be another one like that. Obviously, it will nearly be for all 4 quadrants. But then they can say, well, here's your 2 points. Select the graph that is representing those 2 points. Okay, so that is nearly how it will be framed in your assignments and in your exam, because again, they can't ask you to plot it, but they can give you points with the plots and then say, locate it. Okay, then the one where we need to nearly calculate the gradient or the slope. So again, we can call it gradient, we can call it slope. They again will use it interchangeably in your assignments and in the exam. So just remember, gradient and slope is exactly the same. Okay, so if I give you 2 points, the way we calculate the slope is by saying the difference, and the step before this one could have been the difference in y divided by the difference in x. So we'll take the first point. So let's say here the points was 4 and 5. So remember that's x and y. And 2 and 1. Again, remember x and y. So if we took the first point where it was y equal to 5, we will subtract the other y, which was 1. So the change in y from 5 to 1 divided by the change in x, so 4 to 2. Okay, and then that would have given us 4 over 2. That will give us the 2. What is important is also you don't need to first start with that point. You could have said, okay, but I want to start with this point. So what you will then do is just say, okay, still my y was 1. I subtract the other y, which was 5, divided by 2 minus 4. Okay, then we would have gotten minus 4 over minus 2. And if we cancel out that, because minus and a minus cancels out and becomes positive, we will also get 2. So it doesn't matter which point you use first, as long as you follow the sequence of, if I take y here as my first number, I must take x here as my first number. If I take it y here as my first number, I must take y on the other side as well, or the x as my first number. So always remember that doesn't matter which point you start with, as long as you keep it consistent to say, if this is my first point, that will be then what I use. But when I use it for the one on top and for one below. Okay, so just keep the consistency. But again, it doesn't matter which point you use first, you will get the same answer because those 2 points lie on the same slope. So your answer will always be the same. Okay, so let's go back to these two. Okay, so let's calculate that slope. So the m is the change in y over the change in x. So let's use it. Y is 2 minus, and then it's minus 3 over 2 also minus 3. Okay, so that will become 2 minus 3 is 2 plus 3. And below the line also 2 plus 3, which will be 5 over 5, which is equal to 1. Okay, so there we would have then been able to calculate our straight line as actually y is equal to x. Okay, so that would have been a way by looking at the two numbers, plotting the two numbers, then working out the slope that we now have done in the next section. And now we actually have drawn or created that equation for you. Okay, so the same we can do with this one. So let's again work out the m, follow the same process, change in y, over change in x. So there it is, 3 minus 1 over -1 . Okay, sorry. And again, easy to make the mistake. I actually, instead of the x, used the y numbers. So it was -1 minus 2 that we need to work with. And then it is at the top, 3 minus 1 is 4. At the bottom, -1 minus 2 is -3. Okay, so we getting not a very nice slope, but then your slope is 4 over -3, which we can then rewrite as -4 over 3. Okay, so that is again a way to calculate the slope. So we then have this number of so that is how our formula looks at the moment. We still need to work out what C is nearly for you to get to that final equation that you also need to do. Okay, so the easiest way to calculate the C is actually to use any one of these points and substitute it in your formula. Okay, so if you, for instance, take this first one, so we know that y is 3. We substitute the x, so -1 into that, and that will then be plus c that we will need to calculate. So if we then just simplify it a bit, -1 minus that will be 4 over 3 plus c. So then to get rid of the 4 over 3, we will move it to the left-hand side. So 3 minus 4 over 3 is equal to c. The c will be equal to 1 2/3. Okay, so that's why probably would have gone through there instead of up there. But again, this one was definitely, I would not have been sure about where my cutoff is. So then if I need to rewrite it into the equation is -4 over 3x plus 1 2/3. Okay, so that, again, by just giving you 2 points, you will be then able to firstly work out what your slope is or your gradient. Then by substituting any one of those 2 points back into your formula, you can get your final equation. Okay, so let me just, does that make sense? Is it assisting? Is it making this a bit more understandable? We will go through another one or two of these types of examples. So hopefully it does make a bit more sense at the moment than previously. Okay, cool. So let's let's go to the next one. So another two examples. If you lose me, the load shedding just kicked in. So if there's a slight drop in connection, I will be back in the next few minutes, but it seems like it is hopefully holding. So let me also duplicate this, and then it looks like the same. I just quickly want to check if it is the same questions. No. -1 and 2. Okay, no, so sorry. Let me just get into this. And as what we will also do, that one looks very similar. Okay, what we will say while I'm also working on it, you can also nearly on the side draw this and see what you're getting. So very similar. Was that here they again give you 2 points, and they want you to determine the slope. Okay, so you don't need a grid at all to do this. It helps, but you didn't actually need to have it. So you could have gone straight into, okay, I need to get the slope, and the slope is the change in y over the change in x, which is change in y is 2 minus 1. So there's the -1 over the change in x, which is exactly the same, which again would give us 3 over 3. So the slope would have been 1. So again, you will not be able in the assignment or exam to draw it actually. So this is more if you want to practice and see how it look, but else by just giving you the 2 points, you can go straight into how to calculate the slope. Okay, so just then very important nearly is that formula of how to calculate the slope. Again, I will share this slide pack later tonight with a recording, so you will then have all these notes as well that I have written with the slide pack. Okay, so if we needed to plot it, 2 and +2 would have been there. -1 and -1 would have been there. So again, it would have, because that would have been the next point, 1 and 1. So you would have seen that nearly this one again is going through the origin. So it's very similar to this one, where there was a point 2, there was a point 1, there was a point -2 and 2. So that's why I thought it was the same points that they're giving, because again, it was through that straight line. Okay, so the next one, giving us a bit of difference. So what we will see here is Okay, so if we go through a point 3 and 1, 3 and minus 1, sorry, and easy to make that mistake, minus 1 and 2. So again, it will go somewhere through there. So probably not sure about that cutoff, but again, we don't need to work that out. We need to work out what the slope is. So again, we will need to work out the m. So again, change in y over change in x. Then what we also see is, so let's, any point that was first, so again, if we want to use that one, minus 1, minus 2 over 3 minus 1. Okay, then it becomes minus, 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 so it's minus 3 at the top, 3 minus minus 1, so it becomes a positive. So again, we've got 3 over 4 as our slope. So what you can see in this one is when there's a point in your second quadrant and there's a point in your fourth quadrant, what happens is that there's a negative slope or negative gradient. If your point is in first quadrant and third quadrant, because it's positive, you will see that it has a positive slope. Okay, so again, they can ask you around when is it a negative slope, when it is positive. So when it goes nearly up, positive, positive, it will be a positive slope. When it goes positive but negative, it's a negative slope. Because on this side, you can also see positive but negative. So it will always be very negative, because if you say minus times positive, always minus, minus times positive, minus, positive times positive, positive, negative times negative will also be positive. So that's why nearly when you look at the slopes and you look at your points, if it is in quadrant 2 and 4, you got the negative slope. If it is in quadrant 3 and 1, positive slope. Okay, so again, just things to pick up when you are looking at these kind of things. And the reason why I mention that is because what happens a lot is that they give you these points, and then one of the answers is, so typically what would have happened is with these answers, probably one would have been your minus 3 over 4. One would have been 3 over 4. If you swapped those two around, there would have been an option of 4 over 3, and there would have been an option of negative 4 over 3. Okay, so that is normally how the options that they will give you will work, is that if you maybe said, well, it's the change of x over the change of y, there will be an option for you. If you forgot about the negative, there will be an option for you. So that is what makes it a bit tricky, is nearly, it doesn't matter how you work it out. If you do something nearly wrong in the calculation, there is also a wrong option for you. Okay, so the next one, and we nearly have looked at it already, but just to again reiterate, so M is for gradient. It can also be the slope. Your C is your y-intercept, and that is where it goes through your y-axis. Okay, so sometimes it's very clear, like in this instance, that it goes through -2. So then it is very clear that it will be mx -2. Some instances it is not, but that is again when where we will substitute one of the points within your formula to get it. Okay, so if it is very clear, you can use it. If it goes through somewhere between two numbers, then rather work it out. Okay, so again, we could have seen here, so what they've did with this example is that they already have shown you, well, the change in y is 3, and the change in x is 1. So they already nearly said the m that you needed, the change in y was 3, and the change in x was 1. Okay, so they can again, you could have used that point as well, which is 2 and 4. Could have used that point, which is 1 and 1. So let's just do that as well so that you can see the other ways. So if we said, okay, let's get change in y over change in x. So the point was 4 minus 1 and 2 minus 1. Get exactly the same 3 over 1. Okay, so again, there's a few ways that they can show it to you. So that's why I thought, let me just include this as well, where they actually have already worked out the change. They're now showing that for you on the graph, but they will normally include the points as well so that you can still work it out in a different way than looking at the changes. Okay, so that is looking at it where they give you some other points. What they will also do is where you see it going through that y-intercept, they will give you, if they want you to use that information, they will show you the point. So again, they won't just nearly show you something going through a point and not giving you a bit more of that information. So if I wanted you to use that intercept as the point, they will give it to you as well, unless it is very clear on the graph that is going through a certain point. Okay, so let's look at two more examples, and let me make this bigger again. Okay, so once again, they give us points, so they give us a point of -2 and 1, and 1 and -3. So let's look at x minus 2 and 1. And then they give us another one, x 1 and minus 3. Okay, so again, if I try to connect the dots, I don't really know what that y-intercept is. If they've given me that, then it is something different, but they haven't. So I don't have that. So firstly, again, I will need to work out the slope. So your slope is change in y over change in x. So again, y1 minus 3. So 1 minus 3 would be 4. I'm just nearly doing that already. Then minus 2 minus 1. So it's very similar to one of the previous ones, which is minus 3. Okay, so then we have a slope. Then again, by using that slope, we can calculate what C is. So let's put in that one. So minus, let's put in this one. So we've got actually 1 is equal to minus 4 over 3 times 2 plus C. Okay, and then if we multiply that out, let's just work further on this side. So we had 1 is equal to, so let's say minus 8 over 3 plus C. So I'll need to take that over to that side. So 1 plus 8 over 3 is 2 and 2/3. It's equal to C. Okay, this is quite interesting. Why did I make a mistake somewhere? 2 and 1. Minus 2 and 1. 1 and minus 3 is there. One minus 3 is 4. Minus 2 minus 1 is minus 3. Because that C is definitely supposed to be positive. Okay, so I put in 1, should have been negative 2. That is, so it should have been negative 2 as for x and not positive. So then on this side was actually plus 8 over 3, which then becomes on the other side, when we take it over, becomes negative. So it will be negative 1 and 2 over 3. Okay, which is somewhere there. So you could have now seen I've made that mistake. And then I was like, ugh, okay, something is not adding up here, because if I get positive C, it needs to be going through up there. I'm not really getting it. So that is why I went back to nearly to see if I didn't make a mistake with all the slope, which I didn't, but then obviously with a replacement, I made a mistake. And that is why sometimes, again, I like to do the plot and to nearly draw a kind of straight line through the two plots for me, so that I can nearly see, well, if that C came out as positive, something here is terribly wrong. So then, or I made a mistake here, or I made a mistake here. So then nearly backtrack and see where the mistake was made. Okay, so again, they will not ask you to draw it in the assignment, but as you work through the example, or as you work through the problem, draw it on a piece of paper for you so that it is easier when you calculate this. Okay, then the last example of this is that they've given you a line. Okay, so they tell us you have a straight line of y is equal to x plus 2. Okay, so again, they will not be able to ask you to draw it, but there's a few things nearly I want to show out of it so that when they ask you other things around it, you will be able to identify it. Okay, so the first thing is we know that is your C, so that is your Y cutoff, so that is that point. Okay, so that point of 2, so it is positive 2, it is positive 2. Then the other thing that we have is your slope that is in front of the x, so your slope is equal to 1. Okay, so what that tells me is, and let's put it in front, positive 1. Okay, so if it goes through here, it will be a line that nearly goes through, where it will go through a positive over 2 quadrants, that is. Okay, so now I need to, so that was wrong. So I just, in the previous one, explained that is positive and that is positive. So a line that you will draw through this will look something like that. So it will go positive to that side. Here it is with 2 negatives, that will become positive. So if you needed to draw a line, it would have looked something like that. Okay, we don't know yet if the points are right or anything like that. But what we can do is to say, okay, we've got this is your formula. So let's put in a x of 2. And if we put that in, we can calculate what your y is. So if we put in a value of x, that is 2, we can see that your y is equal to 4. So how this line should have been, and let's take that away, is where x was 2, y would have been 4. So let's do it on the negative side as well. So let's put in x negative 2. So if we have y is equal to negative 2 plus 2, y is actually equal to 0. So where x is negative 2, y is 0, so that would have been our line would have gone through there, and that would have been our straight line. So again, they can give you the straight line, or your equation, and they can then ask you, well, the following two points are on that straight line. And then you need to nearly substitute it in, and then there could have been also the options of 2 and 2 and -2 and 0. Okay, so that is a way again how they can put this into a question, is to say, and they won't add the grid again, they will just tell you that you've got a straight line, x is equal to, or y is equal to x plus 2. Which one of these four options have it that the 2 points are on this straight line? Okay, and then what you will do is, so let's say one of the points was 1 and 3. So what I will do is I will put 1 into x, and in this instance, 1 plus 2, y was actually then equal to 3. Okay, so then that is a point on that line, because when you put in 1, you get 3. So let's say one of the points was 0 and 5. So again, if we say 0 plus 2, 0 plus 2 is equal to 2. It's not equal to 5. So that is not a point on your line. Okay, so that is how they can ask it in your assignments, and in your exam is nearly give you a equation, ask you if these points are on the equation. Okay, so let's just quickly go back to the start and nearly again look at what we've now covered. So again, we're not going to draw a straight line, but they can ask you which lines are the ones that are correct. You were now able to determine the slope by all they have it a line that you need to identify 5 points on it, or they give you the points. And we determine the slope. Then, because we determined the slope, then we can determine the equation. So the first step is nearly, for me, normally it's easier first to get your C value, and then from your C value to get your M. If you can't identify your C value first, then you do M, and one of the points you put back into your equation to then calculate the C, and that is how we determine the straight line. So yeah, so they can nearly with that play around a bit, but there's not too much else that they can ask you with the focus on straight lines. Okay, so this is, it's a short session tonight, but I didn't want to split the financial calculations and the straight lines, because next week I want to fully focus on the basic financial calculations and do that in one session, so that we can fully understand that, and not confuse it with the straight lines. Okay, is there questions from your side on this? I know it was a quick session, and a short session, but I will share both the recording and the presentation with you on the chat, so that you can also go through it. But did this help at least? Is it a bit more clearer now how to work with the straight lines, how to look at the the points, how to calculate the slope and those kind of things. Okay, cool. Okay, thank you then, everyone. Next week, definitely going to focus on the financial maths calculation or basic financial calculations. What I'm going to do in that session is show you the formulas. Again, you don't need to study the formulas. It will be in the presentation that I will share. Also going to show you how to calculate using Excel. I will then share after next week's session the Excel spreadsheet with you so that you can play with it as well, manipulate it, so also use it in the things that you can work out in the assignments and the exam. And I will also show you, if you have a financial calculator, just a few steps on the financial calculator as well. But if you don't have a financial calculator, don't go and buy one. It's very expensive. Rather, I'll then show you exactly how to do it on Excel, so that you can use then the template that I will create for you, so that it is easier. I think everybody nearly works or is starting to work in Excel in working environments as well. So, and just the cost of financial calculators is quite expensive. But if you have it, I'll show you how to use it as well. Okay. So that is it for tonight. I'm gonna stop it and